Good morning. Let me know if the sound works by typing in the chat box, and we're going to get started in about a minute. Okay, good morning. Hi, everyone. Oh, I hope you can see me. Well, my screen. If everyone could just type in the chat that you can see and you can hear everything clearly, we will get started once I know that we're all good. Good morning, everyone. All right, let me just get my screen situated. Okay. I'm assuming there's still a delay. I'm trying to clarify, but as long as the sound and the video are good, we're going to get started. So today's going to be a little different. Instead of asking for comments as we go, I'm going to do my best to review the topics, provide an example of each learning target that we've learned. And if you have specific questions, please put them in the comments and I can address them at the end or, as they come through. Because there's a delay, it's actually a little challenging to keep it a back and forth. So this is what we're going to review today. So we have learning targets 1, 2, 3, 4, 5, 6, and 8. Now 7 is not here, but learning target 7 is actually embedded in anything that involves equations, because learning target 7 is that you could explain the steps that you're doing to solve the equation, knowing that the both sides are balanced. So that really happens all the time, and we do that a lot in class. So hopefully you understand why that is not individual. Rose, I see that you said it's blurry. Is anyone else having an issue, or can you see? Okay, let's see. Is it too blurry to read the words? Because I hope that the work on the next page is a little bit better. Let's see if it clarifies. I actually tried to reduce the bandwidth so that we could have the conversation in the chat. Okay. So let's start. If you're having a really hard time seeing, let me know. If you can see it and it's just a little fuzzy, that's stuff that I'll work on as we move forward. Okay, so here's our first learning target. And just to go back, I'm sorry, if there's anybody in period 1, 2, then your exam is learning targets 1, 2, and 3. Period 3, 4, and 8, 9, your learning targets are all of them. Okay, so just keep in mind as we go through, if you are in period 1, 2, you may not have seen 4, 5, 6, and 8. Okay, here we go. So learning target 1 is where we work on solving equations with variables on both sides. We worked on a lot in this target because we were working with combining like terms and the distributive property. So in this problem here, we first want to simplify our equation so that we're able to solve. Most of us are really, really strong when we see this parentheses, and we know that it's the distributive property. So we are going to distribute. This is 5 groups of x minus 4, which means I have 5 x's, and I have 5 negative 4's, which is actually negative 20. Okay, so a lot of us see that as multiplication. Some of us can actually break out that grouping. So when I rewrite my equation, and I apologize, my handwriting with the mouse is getting better, but not perfect. We have 5x minus 20 equals 6x minus 5. From here, you really do have options, but the goal is that we need to isolate our variable. Some of us see that we have the 5x here and a 6x on the other side. I need to eliminate one of them, or the variables on one of the sides. So I'm going to subtract the 5x. The reason I'm subtracting 5x is because this is a positive 5x. And our goal, when we say we need to get rid of it, we need it to become 0. And the only thing I can do to 5x to get it to 0 is to take away or subtract 5x. So I need to do the same thing to the other side in order to keep my equation balanced. So that right there is actually learning target 7. The explanation that you would need to do the same thing to both sides to keep them balanced. So now 5x minus 5x, we have nothing. That is 0. And I am left with negative 20 on the left side of my equation. So negative 20 equals 6x minus 5x. The x's do not eliminate. This is actually 1x. And I'll write it like this just for now. But a lot of you see this and you just write x, which would also be correct. You're not going to get punished or penalized if you put 1x, as long as you understand that if you have 6x and you take away 5, you're left with 1. And I still have this negative 5 here. So now we've done really good because we isolated our variable to one side. I still need to get the variable by itself. So I need to undo the operations happening to it. If you see here, we have x, and from x, we're subtracting 5. So again, our idea is to get this to 0. The only way I can get negative 5 to 0 is by adding 5. And I also need to do this to the other side of the equation so that it remains balanced. So now here, this has become 0. I have x, and actually I probably shouldn't put a big X through that. I'll just cross it out. And over here on the other side of the equation, negative 20 plus 5. Now for those of us who still struggle with adding and subtracting positives and negatives, you can imagine this negative as a debt. I owe you $20. And if I give you 5, I still owe you 15. For those of us that need a number line, if I'm here at negative 20, sorry, that's a weird negative 20, and 0 is all the way over there. If I move 5 units, 2, 3, 4, 5, good. I'm at negative 15. I'm actually moving closer to 0, a negative 20, and I'm adding 5 units. That's a good question, Rose. And a lot of students struggle with the negatives and the positives. Negative 20, and for those of us that struggle, the number line is a great strategy. Plot your number on the number line. We also have a number line hanging in our classroom above the big chalkboard. You can see if you are at negative 20 and you add 5, you are moving closer to 0. So 5 units bigger than negative 20 is negative 15. And for me, I always think money. That's just my strategy. So I always think I owe you 20. I give you 5, so that's a positive 5. But I still owe you 15. So the solution here would be x equals negative 15. And that one problem had a lot of skills in it. We had to use the distributive property, and then we needed to start to isolate our variable. But that would be a great example of solving an equation with variables on both sides. Again, if there's any questions about this learning target, type it in the chat box, and I can go back to it towards the end. So now we're moving to learning target 2. After we learned how to solve equations with variables on both sides, we learned that there may not be just one solution to an equation. We saw that there could be no solutions, or there could be an infinite number of solutions. And we learned this a few ways. We can solve our equations and identify some patterns, or there's certain things we can look for. So in this example, the left side of the equation is the same in all 3 equations. We did this intentionally to save some time. But if I distribute, I get 8x because I have 4 times 2x plus 4. So now that we know that the left side of the equation is 8x plus 4, let's see some patterns. It's getting very difficult to type with the mouse. 8x. Whoop. And 8x plus 4. Oh, wait, no. So if you take a look at these, you may see the patterns already coming out. You may see them right away. And if you don't see them and you're not sure, when in doubt, just keep solving the equation. Okay, so let's look at this first one. When I simplify, my equation becomes 8x plus 4 equals 8x plus 4. When we learned about infinite solutions, we saw that if they have the same variable, meaning 8x on both sides, and the same constant, that they would have an infinite number of solutions. And the reason that this is, any value that I put in for x on both sides of the equation, I'm multiplying by 8, and then I'm adding 4. So the fact that I'm doing the same thing on both sides to that variable, it can be any number. It could be a fraction or a decimal or a positive or a negative. It will always work. So again, we have same variable, same constant. Yes, the equation is still true and it will always be true. So same variable, same constant, infinite. This next one here, after we simplify, we have 8x plus 4 equals 8x plus 10. So our variables are the same. I'm going to start out with any number, and I'm going to multiply by 8 on both sides. The problem is now, on the left side of the equation, I'm adding 4, and on the right side, I'm adding 10. So no matter what number I put in for x or substitute in, on the right side of my equation, it's always going to be 6 units greater because I'm adding 10 here, but I only added 4 here. So in this scenario, same variable, different constant. This scenario gives us no solution because there is no value for x that would make this work. I'm typing this so that for those of you that are writing stuff down, you have something to refer to. And this gets a little challenging because some of us want to just look at the equation and know if there's infinite or none. And some of us settle for seeing that the variables are the same on both sides, and we automatically say infinite or we automatically say none. There is another part of this, and it's the constant. In infinite solutions, the constants are the same. In no solutions, the constants are different. So identify that key difference. And in the last one here, when we simplify, we see that the variables are different on both sides. So I can continue to solve this. It doesn't matter here what's going on with the constants. The key is that the variables are different. And if the variables are different, we will have a solution. Now, I don't know yet if it would be a whole number, an integer, a decimal, or a fraction, but I know that there will be one solution. Now, we've been working for weeks on how to solve an equation. So for those students that were struggling to just identify these key points down here that we learned, our recommendation in class was, when in doubt, just keep simplifying. If you keep trying to solve, you will get to a point where you would see that either everything worked or nothing worked. So in the first scenario, if I wanted to get rid of the variables, which some of us like to do, when we solve, we like to isolate the variable first. If you took an 8x away from both sides, minus 8x here and minus 8x here, you would end up with 4 equals 4, which always works, and that's always true. In addition, if you decided to take 4 away from both sides, you would have ended up with 8x equals 8x. And if you went one step further and divided both sides by 8, you would get x equals x, which truly means any number equals itself, and that would be an infinite number of solutions. In this middle equation, if you first took the 8x away from both sides and decided that you wanted to keep solving, you would see here that you get 4 equals 10, which never works and never will, because 4 can never equal 10. So there you could see 4 does not equal 10, there's no solution. Or if you took 4 away from the left side, let's say I decided to take away, let me erase this so you can see it. If I decided to take 4 away, subtract 4 because it's a positive 4, oh, not from there. Then I would have 8x on the left equals 8x plus 6 on the right. And this is a problem because, again, what we talked about before, if I'm multiplying this variable by 8 on both sides, I'm still adding a 6 on the right, and I'm not doing anything else on the left. So this would be no solution. This is not x equals 0, and I'm going to write this in big letters. This does not mean this, because 0 is a number, and 0 can be the solution to a problem. So if we have a scenario where there is no solution, you actually want to write out no solution. You do not want to say x is 0. That's a big no-no. And in this last one here, if you continue to solve, just like we did in Learning Target 1, you would get a solution. If we took the 6x away from this side, we would have 2x, and then at the same time, I'm going to take the 4 away from here to move my constants. So 2x equals 6, which means x is 3. So that's the key difference between one solution, no solutions, infinite solutions. There's actually a really good visual for those of you that like this, similar to what we just did. I found this online and I really liked how it was broken out. So if you want a screenshot or take a little picture, it shows the difference. And Learning Target 3 is the explanation of like what it means to have one solution, what it means to have no solution, and what it means to have an infinite number of solutions. So this here is really the explanation. And then at the bottom, they kind of explain it again. If you can't see the visual, I will post it on the website after the lesson, and I can put it on my Instagram too. I'm writing myself a note to do that. But this is a really good one to look at. All right, Learning Target 4. So Learning Target 4 is that we can actually create an equation from a real world scenario. So I'm going to go through this somewhat quickly, maybe straightforward. But let's see if we could break it down. And if you read this at home, try to create the equation before you follow along with what I do. Mr. Caravano needed to rent a moving van. Company A charges a rate of $90 per hour plus a $50 truck fee. Company B charges a $70 per hour fee plus a $90 truck fee. So for what numbers of hours are the rental costs the same? So in terms of breaking out our equations, we like to do three things. First, we like to identify what we know, all the things that are given in the equation, in the word problem. That will help us. Then we identify what we need. And last, we take those pieces and we put them together to create an equation. So here we know a few things. Company A is $90 per hour, and that per hour is big. That's going to be really helpful. And then a $50 fee. So no matter what, you have to pay the $50 for the truck. Company B is $70 per hour and the $90 fee just to get the truck. So we're going to figure out what number of hours the rental costs are the same. So first I see that we're talking about when they're the same, which would be when are they equal. And I'm going to model and create an equation to represent Company A and Company B. So I circled and underlined, I circled what I knew and I underlined some of it. What we need is the number of hours. So this is going to be our variable. Sorry, my squiggles and lines and circles are a little unclear. I'm actually going to erase so that we could see again. So I'm going to compare Company A to Company B because the question is, when are they the same? Company A charges $90 per hour. I don't know how many hours, so I'm going to represent that with my variable, H. So every hour it's $90. After 1 hour it's 90, after 2 hours it's 180, and on and on and on. But they also charge a $50 fee. This doesn't depend on the number of hours. It's just no matter what, you have to pay the $50. So that represents Company A. Company B charges $70 per hour. Again, first hour would be 70, second hour would be 140, third hour 210, and so on and so on. And then they charge a standard $90 fee. No matter what, you have to pay the 90. So this is our equation. This is where Company A equals Company B. From here, you would solve just like you would any other equation. Variables would isolate to one side and our constants to the other side. So if I eliminate the 70H, I can take that away from both sides. And the reason I subtract here is this is a positive 70. To make it 0, I have to subtract 70. So that is now gone. I'm left with 20H plus 50 equals 90. And now I need to undo what's happening to my variable. My variable is being multiplied by 20, and then I'm adding 50. So I'm going to subtract 50 first from both sides. Again, that's learning target 7, where you're explaining why you're able to do that, or that you know you can do that. Whoop. Oh, that just doesn't want to do that. Okay, so I'm left with 20H equals 40. And if I divide now by 20, it's getting a little tight down there. Divide by 20. H would be 2. 40 divided by 20. Which means at 2 hours, these companies cost the same amount. And if we wanted to go back, we could prove that. Because Company A, after 2 hours, you would pay $180 just for the hourly fee, plus the 50. So you would spend a total of $230. Company B, after 2 hours, because it's 70 per hour, would be 140 plus the 90. Plus 90, which is also 230. So if you went back and substituted, you would see that 2 hours is the number of hours where they cost the same. If anyone has any questions about the word problem, type it into the chat box now. Otherwise, we will move on to inequalities. Inequalities are very similar to equations, and we did identify one key difference, which we will go over on the next slide. But this inequality is really work on many things we've done. Distributive property, 2x, two groups of x plus 1, which is 2 x's and 2. And on the other side, 3x minus 5. And our symbol here is greater than. So when I get my variables to one side and my constants to the other, I'm going to eliminate the 2x from both sides to keep this inequality true. And I have x minus 5 is greater than 2, because that's gone. Now I have to undo what's happening to x. I'll add 5 to both sides. So x is greater than 7. Now, many of you are doing this perfectly, and right at the end, you're writing x equals 7. And that's not true, because in an inequality, our solution is a range. X equals 7 means there's only one value that works. In an inequality, any number greater than 7 will work. So x could be 8 or 9 or 10 or 11, and it kind of goes on and on. And the example we like to use in class is, imagine going on a ride at Six Flags. If they say that you need to be at least 55 inches to ride, you could be 56 inches, 57, 60. There's a lot of heights that would get you on the ride, not just one. Now, we talk a lot about reversing the inequality symbol when we divide or multiply by a negative. We talked in class extensively about why this is the case. For those of you that need a visual, here's one for you. In this scenario, look at this number line. We have 3 to 7, so 3 is greater than 7. Oh, I'm sorry, 3 is less than 7, sorry. But if I multiply both by -1, my numbers become negative. And actually, let's look down here. Sorry. This is my original, well, my two inequalities. If you start with this one here, 7 is greater than 3, which we know is true. It's a bigger number. If I multiply both by -1, I'm just multiplying by -1. Those are weird multiplication symbols. But if I multiply both by -1, this becomes my inequality. It became a -7 and it became a -3. Now, if I still had my original symbol, it says that -7 is greater than -3, which is not true. So by multiplying by a -1, I'm actually, on a number line, I'm kind of like reversing their locations, which is why I have to reverse the symbol. And I know for some of you in class, this is a tough concept to understand. And it's one of those things that the more work you do with inequalities, the more it will make sense to you. But when we say multiplying or dividing by a negative, you reverse the symbol. This is really why. Because multiplying or dividing by a negative, you're actually changing the position on a number line of the numbers you're working with. If you need this visual provided on the website because you can't see it that clearly, put a message in the chat and I can add it with the one solution, no solutions, or infinite solutions image. But just let me know on the chat bar. Okay. Whoop, I didn't mean to do that. How's everybody doing? Are we still there? All right, so the last learning target that we are going to work with is learning target 6 and 8. And the reason 6 and 8, learning target 6 is that we can solve an equation with a coefficient represented by letters. And learning target 8 is that we can rewrite or transform an equation or a formula. So they're kind of similar. So they're kind of being merged into one. So let's take a look at this equation. P equals 2A plus B. We want to solve for A. So what we need to do is identify what's happening to A and undo everything that's happening to it. So in this scenario, A is being multiplied by 2, and then we're adding B. So we're multiplying by 2, and then we're adding B. So to undo this, I'm going to take away B, and then I'm going to divide by 2. So let's see how this works. Again, I'm getting A by itself. Okay, so first thing, I'm going to subtract B from both sides. Now, a lot of us see that this is a positive B, so I'm subtracting. So we're good here. And then some of us get confused with how to write this. This over here on the left side of the equation is just P minus B. So you can write it just like that, P minus B. The reason, Rose, that we didn't mention P is because we're first identifying what's happening to A. Just like we would if the equation was 2x plus 5 equals 7, right? If this was our equation, then we're identifying what's happening to x. X is being multiplied by 2, and then we're adding 5. I don't really need to talk about the 7 yet because we're just identifying what's happening to the variable. So getting back to this equation over here, A is being multiplied by 2, and then we're adding B. So I'm going to undo that. We take away B from both sides, so this is gone. And again, getting back to some confusion, P minus B, you can just write it as P minus B. I don't know what P is, I don't know what B is, but I know that no matter what numbers they are, I'm going to take B away from P. So this is what my equation looks like right now, and we're almost done. We've actually already we undid this down here. So the last thing, A is being multiplied by 2. Now this is multiplication. Some of us still want to see this as addition, but this is a coefficient multiplying by our variable. If it was addition, you would have to see the addition symbol. Because we don't have an addition symbol here, and we see that this is a coefficient, we should understand that that's multiplication. If that's multiplication, then I undo multiplication by dividing. And I'm going to divide the entire other side of the equation by 2. 2 divided by 2 becomes a big 1. And on the other side of the equation, we have P minus B was divided by 2. So my final answer, I guess you could call it, if we're rewriting this equation, or as we say, solving for A is equal to P minus B divided by 2. And all we had to do was undo the operations. It didn't matter if the things that were happening to our variable were multiplying by letters or variables, or multiplying by integers. I'm still able to undo anything that's happening. We're going to do a couple more examples of these because I know that this is a sense of confusion for a lot of us. We just haven't really seen equations where we're solving for different variables and there's other variables involved. So we're going to do another one now. If there's questions about these types of equations, then type them in the chat box. This is a great time for us to go over them. Here's another example. We're going to solve here for B. So first thing we need to do is figure out what's happening to B. So B and C here, that's multiplication. So the first thing we're doing to B is multiplying by C. Uh-oh, can't hear or see anything? It says that my strength is still good. Can anyone else let me know if you're having a hard time seeing or hearing? While I'm waiting for responses, I'll keep going because I know at least it'll record for those of us that are struggling to hear or see. In this scenario, B is being multiplied by C, and then we're dividing that entire thing or that entire term, to use mathematical language. We're dividing the entire term by d. So how can I undo this? I need to get b by itself. So I need to undo. We're going to multiply by d. And then we're going to divide by c. And I like the visual like that I'm showing on the right because it shows the exact opposite operations. So in this scenario, if I multiply both sides by d, on the left side of the equation, I now have a times d, which I can just write as a d. You could write it as dA if you would like, because the commutative property says we can multiply in different orders. An inequality word problem, I will try to find one very quickly, and I will do one at the end. Okay. So on the right-hand side, after we multiplied by d, this is a big one. And really what that does, it eliminates the division of d. So it kind of just gets rid of the fraction because that fraction represented dividing by d. By multiplying that side by d, I really just got rid of that. So I'm left here with b, c. So this was done. Check. And the last thing I need to do here is divide by c to get b alone. So I'll divide both sides by c. And now again, this is a big one. So I have b equals AD divided by c. So for those of us that struggle when we see these, this over here is a great strategy. Very similar to the lesson we did, I want to say 2 weeks ago now, where we built the equations. When you see what's happening in the equation, it's a little bit easier for you to identify the inverse operations to undo it. So we had multiplying by c, so over here we have divide. Here we have dividing by d, over here we have multiplying by d. Yes, it definitely can be done in one step. The reason we could do it, yes, you can, to clarify. The reason I break it out is for the students that are still learning how to undo an equation. But yes, Manny, you could have actually multiplied by d and divided by c at one time. And what you could have done is just multiplied by d over c. And it really would have been the same concept. But yes, good call. Okay, so we're going to do one more of these. So again, we're solving here for t. We'll identify what's happening. T is first being multiplied by 2. And then we're adding 3w. Adding 3w. So to undo this, I'm going to work back to the beginning. I'm going to take away the 3w. And then I'm going to divide by 2. Good, Rose. And again, I really like this visual because it shows you the inverse operations, and it kind of shows you like almost the, I don't want to say the best order because you can solve these many ways, but it's probably the most straightforward. So here, following our little checklist, we'll take away 3w from both sides. On the right side, I'm left with just 2t. And on the left side, x minus 3w. And again, I can't really take 3w away. Like I can't combine them because they're not like terms. So I can just write them this way. So I did that. And then the last thing, I'll divide by 2. Divide by 2. Divide the whole thing by 2. So this is a big one. And I'm left with t on the right. And on the left, I have x minus 3w divided by 2. So what does that do for us? That actually simplifies and gets our variable by itself, the variable that we were asked to get alone. If anyone has questions about these types of equations, please type them now. Otherwise, I'm going to get an inequality word problem to finish up. if I can get a good one. Okay, let's see. Okay. We'll do a word problem, and I'll type it out so that we can see it. Keith has $500 in a savings account. I feel like this might have been one of the examples we did in class. Yes, Rose, to go back to that, we're working backwards. We're really undoing whatever's happening to the variable that we are trying to solve for. This word problem might have been one of the ones we did in class, or we did one just like it, I think. Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. I'm sorry, I typed that wrong. He withdraws $25 per week for food, clothing, and movie tickets. I love the movies. How many weeks can Keith withdraw money from his account? So the question here is how many weeks? So there's not necessarily one answer. He wants to have at least $200, which means he's okay with having more. If he has 205 or 220 or 250, he's cool with that. So when they say at least, this little phrase here should really signify to us, if that's a word, that this is an inequality. So let's put together what we know. He has 500 and he wants to have at least 200. He's going to withdraw 25 per week. And we're looking for the number of weeks. So we're going to take away 25 per week. So this is what he has. He has $500 and he's going to take out 25 per week. Now this entire amount needs to be what compared to 200? Because the symbol is where a lot of us see at least, and we see like least and we think less than, so we do this symbol, which is less than. But the problem is that's not really what we want to think here. We need to think about the scenario. This entire amount is what he has left in his account. What does this number need to be compared to 200? If you want to type it in the chat, you can. What is this number, whatever number it becomes, what does it have to be compared to 200? Does it have to be less than or equal to 200, or does it need to be greater than? Think about it. He wants to have at least $200. So think about an example of money that he wants to have by the end of summer. Is $175 okay for him if he wants to have at least 200? Like, which number works for him, 175 or 225? Which values would work? Because that's going to help you figure out the symbol. Yeah, so we need this amount, whatever amount he has at the end of the summer, to be greater than or equal to 200. Because this 200 can be the smallest amount. At the least, he could have 200, which means he could have 201, 205, 250. But we need this value, whatever this becomes, to be greater. So this is our equation, this is our inequality. Even I make that mistake sometimes. And we're going to get a range of solutions. And this is a really good one to practice with because we're going to have to work with a negative number here. If I need to solve and get my W alone, I'm going to identify what's happening and undo it. First thing I'm doing here is multiplying by negative 25. And then we're adding 500. And some of us are like, wait, how are we adding 500 if there's this little negative symbol here? The 500 is positive, right? So I'm multiplying by a negative 25, and then I'm really just combining these, so I'm adding them. That negative is actually the negative 25. So to undo this, I'll subtract the 500, and then I'll divide by negative 25. And this is our key here, because when we work with inequalities, this is going to be where we do something a little different because we're dividing by negative. So let's get moving. Subtracting 500 from both sides. This is now gone, and we're left with negative 25W, and our symbol is greater than or equal to negative 300. First step, done. And last thing, divide by negative 25. So this is a big one, and we're left with W. I'm actually going to change the color here. W on the left, and on the right, we have negative 300 divided by negative 25, which is a positive 12, because 25 goes into 300 12 times. Now the symbol here, this is going to reverse because we just divided by a negative. And if you think about this scenario, it doesn't make sense. Like if this was my sign, so say I stuck with the original by accident. Okay, say this is what I came up with. In the scenario, that doesn't make sense because the number of weeks can be greater than or equal to 12. That means if he takes money out for 13 and 14 and 15 and 16 and 17 weeks, that he's going to have more than 200 at the end of the summer. So this really doesn't make sense. The scenario that makes sense is when we do the proper operation with our inequality symbol. Because we divided by a negative, we reverse our symbol, and our solution here would be W is less than or equal to 12, meaning that the number of weeks needs to be less than or equal to 12. So he can take out money for 12 weeks, 11 weeks, 10 weeks, 9 weeks, 8 weeks, 7 weeks, on and on until we get to 0. And he will have at least at least $200 at the end of the summer. Okay. Does anyone have questions about this scenario before we wrap it up? Okay. So just to recap and go back to the beginning to go over all the things that we've done. The exam tomorrow and the period 3, 4, and 8, 9, you're taking it tomorrow. And period 1, 2, their test will be on, yes, multiplying or dividing by a negative. Okay. So multiplying by a negative, wait, why 12? Wait, let me go back here. Sorry, I'm just seeing these questions come through. It's multiplying or dividing by a negative. If you need a scenario, I could probably pull one up, or I can put them on the website after. But let's see, 12. Did I not do the math right? Yeah, no, 300 divided by 25 is 12. 25 goes into 100 4 times, and then another 100 would be 8, and then another 100 would be 12. So our value here by the division is 12. Yeah, so period 3, 4, and 8, 9, your test is tomorrow. And it is on learning targets 1 through 8. So let me show you up here our learning targets for the test. So period 3, 4, and 8, 9, this is your test. There are, I want to say I actually have it right in front of me. Hold on. I have the test. There are 12 questions, and it covers each of these learning targets. Some of them, there are like 2 questions per learning target. So just like the quizzes, each question has its own grade based on our 4-point scale. And in the grade book, your test grade will be broken out for every learning target. So you can see which questions you were really strong with and which questions you may need to redo. Yeah, so that's what we're going to do tomorrow. And then Thursday, we're going to start our new unit. And there is some information on the website for those of you that want to get a head start on the next unit. There's some really great resources there. The website www.mathwithmrsc.com. If you have any questions about any of the resources, just email me. You could also send me a direct message on Instagram, or for those of you that use your Google account from school, you can do a Google Hangout. That's actually, I'm using the Lakewood Room 29A@gmail.com. You can Google Hangout me, so if you have any questions. Will we do an online lesson on Wednesday? Probably not, only because we're starting something new on Thursday. But if there's something really, really important that you would like reviewed or to go deeper on, you can let me know and we can. I'll be home. So if you want to do another one Wednesday, we can. All right. If you have any questions after this, feel free. You can email me, comments, send me a comment through my website, Instagram, Google Hangout, whatever you need, I'm here. And get ready. It's tomorrow. You're going to do great. Take a look at any of the posts with any of the materials just to be prepared. But if you've done well on the quizzes, you'll do great on the test. It's really, all the quizzes are meant to kind of lead you to this point. And I feel really excited that your first exam is tomorrow. Thank you, because we had 14 people today, which I think is more than last week's. I think last week we had 13. So my goal is to get up to 20. So keep spreading the word to your friends. And, we'll do this again sometime. Thank you all for coming on. I appreciate it. And I will see you tomorrow. Enjoy the rest of your day off. Enjoy the weather. It's beautiful. Have a good day.